So before we get started, I think there was a question on 29, problem 29, because I think that was, yeah, or not 29, let's see here, because it was 19 through 20. Yes. Okay, so 29 was one of the problems, yes? Yeah, we can look at homework 1.3, yes. So we'll look at 29. F of x equals the absolute value of x is translated 2 units up, followed by a horizontal stretch of 2. So we have this function here, and we're going to perform a translation 2 units up, followed by a horizontal stretch by a factor of 2. Now, the first one we're going to look at is our horizontal translation, our movement up or down. Now, the way we define this movement, we'll call the next one g of x, is equal to f of x plus k, where k is the amount that we're moving the function up or down. And our value of k for this here is 2. And since we're moving it up, it's going to be positive 2. Now, f of x is still the same, so it's still just going to be the absolute value of x. Now, since there's nothing in front of the absolute values, nothing we need to do it, we can go on and drop those parentheses. Questions about our first transformation up 2. Now, our next transformation was a horizontal stretch by a factor of 2. Now, horizontal stretch in the general form was f of a times x, which for us here is going to be g of ax. And we call it g of x because we're applying it to g of x, not f of x. And a is going to be the amount that we stretch or shrink this by. But we do have to be careful with horizontal. Horizontal was the only one we had to take the amount and flip it. We put it as 1 over that amount, or we flipped it. Well, 2 flipped becomes 1 over 2. Or if we put it over 1, we get 2 over 1. So the amount that we're plugging in for this a is 1/2, not 2, because it is a horizontal stretch or shrink. Horizontal stretch or shrink, we take whatever number they gave us and flip it, and then plug it in for a. Now, we don't have g of x anymore. We have g of 1/2 x, which means every x in g of x has to be switched to 1/2 x. So we'd still have the absolute value bar, but instead of x inside of it, we're going to have 1/2 x plus 2. And lastly, we can drop those absolute value bars, telling us that our final function is the absolute value of 1/2 x plus 2. 29. So that is if we did 2 up and a horizontal stretch of 2. Yes, sir. Okay. All right. We'll be. All right. So.
Rachel, please call the office.
Yep.
Rachel, please call the office.
For this problem, if it was up to an horizontal stretch of 2, this would be the function. But as I'm looking at this now, it was not up to, it was what? Right to. So, all erase that, and erase that. Now, the reason that this is making a difference because up and down was f of x plus k. Left and right are, I actually said horizontal, said the right thing, but I was writing x minus h. Horizontal translation, f of x minus h. This is our left-right, where h is the amount that we move left or right. Now for us here, h is 2. So the value of h is positive 2. And when we plug it in, we get x minus 2. Because h is our movement left or right. It's 2 units to the right. H is positive 2. So we plug in positive 2 for h. And in the form, it gives us this x minus 2. Now for here, we're going to plug x minus 2 in for x. So every x is going to replace with x minus 2. So we don't have the absolute value of x anymore. We have the absolute value of x minus 2. Yes. Now at this point here, we can replace or drop the absolute or the parentheses because we don't need them anymore. So this is telling us that right 2, if we move the absolute value of x, that function right 2, we get the absolute value of x minus 2. Now, as I said before, with our value of a, it is still this horizontal stretch at 2. We're going to flip it, giving us this g of 1/2 x. And just like before, we're going to replace every x in g of x with 1/2 x. So we still have the absolute value bar, but instead of x, we have 1/2 x. So I have the minus 2. So our final function here should be 1/2 x minus 2. Yes. Mm-hmm. And if you put x over 2, that's fine too. This is still the same answer. Any other questions on 1-3? Any other questions on 1-3? 27? I'll mark that again. 27. Erases here. So 27 from 1-3. We have a vertical stretch of 2, followed by a translation 1 unit up. Vertical stretch by a factor of 2, followed by translation 1 unit up. Okay. So here we're going to start off with our vertical stretch. Now vertical stretch is our a times f of x. Vertical stretch and shrink, we use the number exactly what it is for a. So they tell us that it's a vertical stretch of 2. It means our value of a is 2. Now at this point here, we can replace f of x with its function. Since it's still just f of x here, the other side is still x. At this point here, 2 times x is 2x. Questions on our vertical stretch of 2? Our second transformation is up 1. So this here would be our g of x plus k, where k is the amount we're moving up or down. Since we're moving up 1, k is going to be positive 1, so we're going to have plus 1. Now we can replace g of x with its function, which is 2x, telling us here that h of x is 2x plus 1. questions on this here? All right. We're going to move on to our notes for today, 1.4. Now, equations of line. We have three main types for equations of lines. Our first one is slope-intercept form, point-slope form, and two-point form. Slope-intercept form. Comes in the form of y equals mx plus b, where b is the y value of the y-intercept, where it crosses the y-axis, and m is our slope. And do y'all know why we call this slope-intercept form? Because the two main parts of it are slope and an intercept. So we call it slope-intercept form, because those are the main two parts of it. Our second form that we have is point-slope form. Y minus y1 equals m times x minus x1. And just like with the previous equation, we call this point-slope form because we have a point and we have the slope. Now the x, y, that is just the input-output, our dependent and dependent. The x1, y1 is signifying that this is a specific point. And they go together. That is a point. And just as a reminder, we do have our slope formula. Y2 minus y1 over x2 minus x1. Whichever y value goes first, its corresponding x value has to go first as well. Whichever y value goes second, its corresponding x value goes second. Now the bottom, given 2 points, first use the slope formula to find the slope, then use the point-slope form with either given point. Now there is such thing as two-point form. I would not write this down. So y minus y1 is equal to y2 minus y1 over x2 minus x1 times x minus x1. This is technically two-point form. This is the two-point equation of a line. Now the reason I say not do it this way, because really all we did was we took the point-slope form, and instead of using m for slope, we plugged in the equation for slope to get this here. I think there's too much going on for this here. Might as well just find the slope and use a point in the slope. So the main two we're going to use for this here is slope-intercept form and point-slope form for the equation line. And that's the main thing we're going to be doing with 1.4. We're finding equations of lines that match the data given. Now, if we look at this here, this first one, writing the equation of this line, the graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of the line that and interpret the slope. So we want to write an equation of a line. That's one thing we're doing. And two, we're going to interpret the slope. The asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance? Okay. And then once we get all that done, we want to know how long it takes the asteroid to travel 17,200 miles. So we need to find the equation of the line, interpret the slope, and then answer this question. So we're doing three things. Now they gave us this graph here to help us find the equation of the line, our slope. Now they did give us two things. One, they did give us a point, 524. And they did give us a second point. It's just not directly listed as 524. But it's another nice point. 0, 0. Even though it's not listed, we do have 2 points. We can find the slope. So to find the slope, m is equal to y2 minus y1 over x2 minus x1. So we do have 2 points here, so we do have 2 y values, 2 x values. It doesn't matter which y value we pick first. We just need to pick one of them. So what's the first y value we could use? 24, yes. Its corresponding x value would be 5. So 524. X comes first, y comes second. So we'd have 24 over 5. Since we picked 24 to go first, 5 has to go first. What's our other y value? 0. And its corresponding x value is 0. Now that we've plugged those in, we can calculate the slope. There's 2 main ways we can do it. One, we do 24 minus 0, which is 24. 5 minus 0 is 5. Does that reduce? Now the other way we could do this is 24 minus 0 over 5 minus 0, and let the calculator tell us it's 24 over 5. So in a point, yes, x comma y. Part of the reason we do x comma y is one main reason and one main reason specifically. X comes first in the alphabet. X comes before y. So we do things in alphabetical order. And that is all based off the rules that we get from number theory, which is a branch of mathematics. Questions on how we found the slope? Now, one of the main parts of this is to interpret the slope. What it means by interpret the slope is to put in words what the slope is telling us, what it is describing. So if we look at this here, our 2 variables are x and y. X is denoted as what? Time. And y denotes distance in miles. So they told us that the slope is 24 over 5. 24 is our distance in miles. 5 is our time in seconds, yes? So change in y over change in x. So what we're saying, and what this slope is saying, that is for every 5 seconds, it travels 24 miles. We just interpreted the slope. That's it. When it says interpret the slope, it's what is the slope telling us? Yeah. So it tells us in the graph. So normally, I mean, we could say for every 24 miles, it takes us 5 seconds. Normally, we want to put the x, the dependent first, or the independent first, the one that's changing. So for every 5 seconds, it travels. Yeah, it travels 24 miles. So for every 5 seconds, we're traveling 24 miles. Now, this is not the only way we could write this. Because if we reduce this fraction, 24 over 5, we told the calculator, give it to me as a decimal, 4.8. For every second, because now the denominator is 1, it travels 4.8 miles. So there are different ways to write this. But as long as we're still describing the slope, that is fine. Okay? And even on the assignment, I will read your description because it will ask you to interpret the slope. As long as it's saying what the slope is, we're good. Because here, for every 5 seconds, it travels 24 miles, it is describing the slope. Now, we can't say for every 24 seconds it travels 5 miles. That is not the correct interpretation.
So we're not doing anything with the number 32.
We will eventually, because at this point, we've interpreted the slope, yes? We still have to find the equation of the line and then see how long it takes it to travel 17,200 miles. So there's 3 parts to it. We got the interpreting the slope done. But for us to figure out the time, we do need the equation. Okay? Equation of the line. Now we have 2 forms. Y equals mx plus b, and y minus y1 equals m times x minus x1 point slope. We have slope, intercept, and point slope. Now the big way we can tell which one we can use, well really we can use both. Do we have a point and do we have the slope? Yes, so we can use point slope. The main way that we know we can use slope intercept is if we know the y-intercept, where it intersects the y-axis. Do we know the y-intercept? Because the y-intercept is where it crosses the y-axis. Do we have a point where it crosses the y-axis? 0, 0. So the b value of the y-intercept, the y value of where it crosses the y-axis, if we have a point where the x value is 0, we can use slope-intercept form. Because the value of b for this here, where the y value of the y-intercept is what? 0. So we could use y equals mx plus b, because m is our slope. And we found the slope to be what? 24 over 5. So we can plug that in. 20 over 4 over 5x plus our y value of the y-intercept is what? 0. M is slope. Now at this point here we can reduce this equation because we'd have 24 over 5x. Do we need the plus 0? No, so the equation is what? 24 over 5x. 24 fifths x. And that's the equation. So we found the equation of the line. We interpreted the slope, yes? Last thing we need to do is determine how long it takes it to travel 17,200 miles. Now we can use the equation of the line to figure this out. X or y, which one is distance? Y is distance, yes? X is our time. So which one are we solving for, X or Y? Because we're asked, what did it ask? The amount of time, yes? So we're trying to find the value of X, because X should give us our time. So we have to plug 17,200 in for Y. And we have to find the value of X. Questions on how we set this problem up? So we're solving for X, yes? What do we need to do to get X by itself? We need to divide it by what? The number. Because we need to get that number away from X. 24 over 5 divided by 24 over 5. Anything divided by itself is not 0. 1. Anything divided by itself is 1. Even if it's a fraction. Because 24 fifths divided by 24 fifths is 1. And what that leaves us with is X. So 1x, or just X. Now we do need to divide the other side. Our 17,200 we need to divide it, 17,200, is being divided by 24 fifths. $3,583. Let's see what it asks for. About how long does it take? Well, we'll approximate it here at 3,583 seconds. Just in case you're wondering, that is approximately 1 hour. It just asks how long does it take to travel that far, 3,583 seconds. Yes. Yes. And just for reference, we do realize that is insanely fast, yes? Yeah, because if we looked at this here, the distance from here to Siloam, well, because what I know for sure is if we went from here to the Arkansas border, that is 7 miles. So if we were traveling at this speed, it would take you approximately 1.45 seconds to get from here to the border. Arkansas. So it is that corner, that S, but approximately to be able to do that, it would take, well, right now. Yeah. It actually took me longer to say that's, or the sentence of how long it would take there than it actually would take there. Because from here to Tulsa is about 80 miles. So from here to Tulsa, I think it's about 80 miles. Because y'all have had to go to Tulsa before, yes? So it's saying traveling at this speed, it would take you about 17 seconds. Yeah. So as speed or time? So 179 seconds or 3 minutes. So, all right, guys. So the three things this was looking for was 1, to interpret the slope. For every 5 seconds, it travels 24 miles. 2, the equation of a line. Y equals 24 fifths x. And 3, the amount of time it would take it to travel 17,200 miles. 3,583 seconds. So we did have to find the slope. Yes. Mm-hmm. Yep. So we did need to find the slope, but we didn't use that as part of our answer. But we did need to find it. Yes. Questions on this here? Let's look at this next one here. The graph shows the remaining balance Y on a car loan after making X monthly payments. Write an equation of the line and interpret the slope and y-intercept. What is the remaining balance in 36 payments? So 1, it wants us to write the equation of a line. Interpret the slope and y-intercept. There's 2 parts there. And then find out what is the remaining balance after 36 payments. So here, there's several things we need to find. We need to find the slope. We need to tell what the slope and the y-intercept are telling us. Find the equation of the line, and then answer this question. First thing we can do is find the slope. We need to find the slope of this line. This time they did give us 2 points. They gave us 0, 18, and 10, 15. For the slope? So give me one to go first. So that'd be x, 18. So we can say 18 over 0, y over x. Our other y value is 15, and the x value is 10. So we picked one of the y values and put its corresponding x first. So here we picked 18 and 0. Now at this point here, if we did this by hand, 18 minus 15 is 3. 0 minus 10 is negative 10. Now this doesn't reduce, so our slope is negative 3 over 10. I like putting the negative up top. It's not wrong to leave the negative on bottom. I just like putting it on top or in front. So, did you get to negative 3/10? Okay. So I'm going to show this again because there was a question about order of y's, how we put the y's on top. Now, you don't have to write this because the other way we could have written this is 15 minus 18 over 10 minus 0. Okay? So you don't have to write this. Because if we did this again, 15 minus 18 is negative 3. 10 minus 0 is, do we get to the same thing? Yes. The only thing you need to be careful with slope is making sure that our values line up. Because if we have them out of order, because 15 and 0 are not the same point. Let's see what happens here. 15 minus 18 is indeed 0 minus 10 is negative 10, so this is telling us it is positive. If we have a positive slope, it's increasing from left to right. Is this graph increasing? No, it's decreasing. It's going down. Yes, sir.
The black one right there?
Mm-hmm.
Okay, John says 3 is positive and 10 is negative.
Yeah.
You just switched to both.
Oh, okay.
Yeah. Because the negative, we can move it from the top of the fraction to the bottom, especially if it's 1. We essentially factor negative 1 out and put it on top. Mm-hmm. So this here tells us our slope is negative 3/10. Negative slope should be decreasing from left to right, yes? Is this picture, the graph they gave us, decreasing? So does that align up with our slope? Yes, because we should expect a negative slope to be decreasing going down. Okay. So we found the slope. Next thing we need to do, since we have the slope, let's interpret the slope and the y-intercept. So the slope is negative 3/10. Yes? Now our x is the number of pavements. And the balance is what? So our y value is balanced in what? Thousands of dollars. So slope is negative 3/10. So 10 corresponds to our number of payments. So for every, what? 10 payments, the balance does what? Goes down or decrease by $3, yes? I sure as heck hope not. Because what was our balance in? For every 10 payments, the balance goes down 3,000. We use 3 because, again, we denoted the y value in thousands. It makes it easier to view. It makes it a little bit smaller so we can actually see the graph better. So this is our interpreting the slope. Now we also need to interpret the y-intercept. Because it asks us to do what? Interpret the slope and the... So the y-intercept is what? 0, 18. So since the x is 0, how many payments have we made? 0, because that's x is number of payments, yes? It does go down 3. But the y value is in what? Is in thousands of dollars. Now, the y-intercept tells us the what? The starting balance. So the y-intercept is the starting balance at $18,000. So our slope is saying that for every 10 months, we're paying $3,000 off. The balance goes down $3,000. The y-intercept tells us that the starting balance is $18,000. Questions on this here? Two things left. We're going to find the equation of the line, and then we'll figure out how long it takes us to pay, or how much money we have left after 36 payments tomorrow. So equation of the line, since we do have the y-intercept, 0, 18, the 18 tells us that the value of b is 18. What is our slope? So the equation of a line, y equals negative 3 over 10 x plus 18. B is our y-intercept. Actually, we do have time. So the question on how we found the equation of line, the slope, interpret the slope, interpret the y-intercept. So most likely the bell is going to ring before we get finished with this here, but we're going to go on and finish. Don't put back up yet. Because what is the last thing it's asking for? Remaining. So what is the remaining balance after 36 payments? Payments is our x. So to find y, our balance, we have to plug 36 into x. And at this point here, we can do it by hand or in the calculator. So we would do this in the calculator, negative 3/10 times 36 plus 18 is 7.2. Or we'd say that the remaining balance is $7,200. Because since all the numbers on the left-hand side, on that side, y is already by itself, the variable is already by itself, the rest of it's just numbers, we can plug it in. The previous one, the variable was not by itself, so we couldn't just plug it in.